Hello, everyone. Thank you. Good. First, foremost, my name is Anirudha Jadhav. I go by Ani. I've been working with Solar Lucene back since 2005, 6-ish. Been with like Solar 1.4, and it's always been a fun journey with the search community. This particular conference has been awesome. I met a lot of folks whom I've been in other conferences at in like 2010s. So it's just whole nostalgia thing coming back into search. Today's focus is going to be primarily on OpenSearch and how we can use OpenSearch and build core features for builders, users, and take a step towards observability. And the most important thing is observability as a solution shouldn't be limited to only what OpenSearch should do. So we started our work a few years ago. We've been slowly and steadily chipping on with it. The community has been helping up. So we'll go through an entire journey, touch upon major aspects of the project, things we have released this year, and the plans going ahead. This is the entire team. This is whose work I'll be representing. They've been all here. There are a lot of folks in the community who's also been contributing. So thanks to people there and there to make everything over here happen. So for today, we'll cover quick introduction about observability, what we are doing, how we think about it, where we started, and from there touch about what does it mean to have fundamental differences in languages and accessibility. If you can't use something with a query language, natural language, or with a UI that you can click and drag, how easy is it for you to do analytics, and what are the fundamentals of that? We'll jump into the observability stack as we think of it. Things may change and get added. We'll take a lot more feedback over here. Majority of the theme will be GitHub. Everything I'm going to talk about is on GitHub. Most of the things I am talking about are screenshots from GitHub. So most things will include GitHub links. Everything we do is open and everybody can start contributing into it. We'll talk about how we have brought together metrics, logs, and traces in OpenSearch together, how you can do correlations, and the foundational pieces that other builders can use to build their own products on it. Our integration with OpenTelemetry. We started this a year ago. We've been constantly on this and keeping more and more products, protocols, formats from the OpenTelemetry suite in OpenSearch. Simple schema systems that is compatible with OpenTelemetry, OpenMetrics, and few other schema platforms, and how to have those physical manifestations in OpenSearch. Instant on observability, and then last leading into high scale, low cost. How do you bring in Apache Spark? How do you tightly integrate it into the experience of OpenSearch and don't have multiple things to manage, but make it a seamless, endless end user experience that they can do high scale, zero ETL observability. Cool. So it all started here. I think a few years ago, right after the fork, we were thinking like it's just log analytics. How do we do metrics tracing? Do we do metrics on our own? Do we do traces on our own? What are going to be our key tenets? How do we function everything? Since this post was written, I think up until today, we haven't deviated. I think we've been on the same tenets and same principles, keeping on building and evolving and making improvements. The three most important things I've been following through are open instrumentation. Instrumentation is important for observability. We started with how to get data in, start supporting platforms and protocols that are open, and keep them compatible with the schema systems. So we don't have to do dual work or figure out where the fields and things are. Second is connected entities. Now, how do you have a single database with multiple indices and know what is in which index with what field and how they're correlated? And without correlations, you really don't have analytics or observability or many other use cases that you want to go towards. And the other important factor that comes in is with connected entities, it's not just open source. Our customers, people, even I myself, I don't use only OpenSearch. I use other systems like Prometheus, Victoria Metrics. There are many other players and platforms. How do we integrate with everybody together and make the visual and analytical journey seamless? So how do we get data connected? That's the second part. A third part is programmability. So we are shipping SDKs, libraries, and mechanisms for you to contribute data and pieces of logic or domain knowledge, which will make the whole bigger. Currently, we are more focused on the framework and the platforms. There are mostly builder use cases and framework use cases in here that I'm going to talk about. Going ahead, before we jump into observability, the first thing to answer is key fundamental differences of how you operate and logically think about stuff. Today, we think about adding a search query as search or query. I would say fundamentally, if you go deeper, filtering is simply a very narrow term. All it means is removing some information. Then we have query, which is a little bit of a broader term. And query effectively encompasses how do you want to find and retrieve data. It's all about retrieval. Now you're beyond just filtering, but retrieving, maybe you do some joins and group bys, but it's still retrieving information. In the space of observability, both of these are limiting, but we ideally are used to logging and grokking everywhere. So for us, discoverability is more important. And for discoverability, you want to unveil new information, new patterns, new things that are not easily visible to you. How do you find like duplicate lines that are available and dedupe them and figure out patterns? Log patterns is one good example. How do you do all of these things not with UI, but language constructs so you can build on them? Use ML constructs as a language construct so you can build on them and not have always a UI for doing one and only one thing. For all of these motivations, we started a project a long time ago, 2020 almost or before, called PPL, piped processing language. Major inspiration is very common Unix, and many other people do this. But the fundamental thing was, how do we build this language? What are the features, and how do we grow it for observability with feedback? I think today we've been year 3, we're still improving, we're still going there. Let's talk about PPL more. So this is a whole array of what PPL supports today. So I'll go through a brief overview of the language before I jump into what we built with it. So as a brief overview of language, it's pretty simple. You have a source, and then you have pipes as conditions. In conditions, you can use commands, functions. To operate the language, you have interfaces, administrative interfaces, and management interfaces. The language has various commands like anomaly detection, dedupe, describe. Evaluations can use custom expressions, grok. You can have runtime fields and runtime expressions. You can use patterns to define fields within your data which is undefined. It's very rare that you know what field you want before you ingest your logs. So you need this grokking functionality and parsing functionality. Then you have where command. Stats command is one of my favorite commands. It's very simple, just stats, but it does so much. All it has is x by y by z, and you can have in all these dimensions any aggregation you want. So once you put a stats command, you can do multiple aggregations in x, multiple aggregations in y, and you can span it, which is equivalent to bucketing. So with these set of commands and capabilities, now you get a fundamental construct of how do you operate for discoverability and explorability. Majority of the use cases use this for investigations, and we use this for developers building the platform and for users to interact with also. One question I get regularly with PPL, like, is PPL only OpenSearch? Is it only supported by OpenSearch? I think that's where this slide is pretty important. I will not explain too much, but the whole core idea is PPL was meant as an independent language construct with no bindings to OpenSearch. It lives in the OpenSearch project, but the whole language is fairly independent. Anybody can build PPL as a language layer on any other database. The core constructs for those are available in the language spec. Today, we have implementations for PPL in OpenSearch. PPL is available as a language in Spark. So the Catalyst engine in Spark has PPL available as a language. We support Prometheus and PromQL with PPL. You can have PPL operate Prometheus, or you can have PPL bypass PromQL. So as a user, you have options to do both. Any other integrations, you can just keep on adding other languages and other systems to make a holistic multi-data source experience. We have visualizations in PPL. Now that you're connecting to multiple languages, you don't really need to redo your visualization stack in every other language. If you're reading Prometheus, you don't want to redo visualizations in Prometheus or Victoria Metrics or something else. If you're doing from S3, the same thing is reused everywhere, and that's where the PPL-based visualization stack comes in pretty handy. This is our world view in 2021. So we've been just constantly building on top of this. I think at some point this needs to evolve, but for now, I think we've had most of the pieces that we imagined in 2021. I'll just outlay a few key pieces. The center of everything is PPL. PPL is where builders management UIs, solution UIs, APIs, everything goes at PPL. This makes development, debugging, testing, maintenance very easy because there are no APIs. There's just one language construct that operates data interactions. Below PPL, how do we operate different forms of data? So we have pushdowns, direct queries. It goes to OpenSearch. It goes to Spark and S3. It can use accelerations. Most of these pieces work together, so the user doesn't need to know about it. The developer doesn't need to know about it. He just builds his tools and solutions on top of it with PPL. Now, while we are using data, you want to understand schemas, and the schemas come from OpenSearch simple schema. The simple schema is not a new schema system. It is simply a physical manifestation of OpenTelemetry schemas and how they map into our index structures. So if you're using OpenTelemetry export or the other pieces, they will directly map into the simple schema, so we can manage them in a uniform way. And while you're doing all of this setup, every time a new customer starts in OpenSearch, he doesn't need to do everything all over again, like set up dashboards, set up configuration, set up alerts. So the idea was all the way on the left is integrations. And integrations is this instant on mechanism where you just have all these configuration elements together, you hit one button, you get everything. This started in 2021. I'll walk through the journey of how it came to fruition and where we are today and where we're going next. So let's start with metrics. With metrics, we have metrics in OpenSearch. Metrics in OpenSearch can be generated with telemetry data, time series data stored in OpenSearch. But majority of our users, even myself, I use metrics on Prometheus. Prometheus is very popular. So the core idea over here is bring your own metrics. So we allow OpenSearch to connect into remote data sources, pull in the metrics. This is a metric analytics UI where you can pull all the metrics, manage through attributes, sift through multiple metrics, and pull them into a dashboard. For metrics, one of the key languages the developers work with is PPL. So it gives them a unified mechanism to code. As a user, many of us want PromQL because we are familiar with it. So PPL provides a language bypass construct. So in the language itself, you can have a response bypass or query bypass. If you're doing a query bypass, you can take user input, but the responses are still normalized to what the visualizations understand, to what the development stack understands. So you don't have to worry about parsing two different things and maintaining how different formats are returned. Next, what if you don't have Prometheus? You can get metrics from Data Prepper. A Data Prepper is an ingestion platform which can do metrics from logs. Similarly, metrics from logs can also come from as if you're ingesting just metrics from a log, or it can come from OpenTelemetry exporters and OpenTelemetry collectors. All of these metrics come together in OpenSearch. What you need to do over here is simply get to a UI, get the metric that you're seeing, and save it as a metric by defining what you're seeing. Because we don't have metadata around the metric, this one step is important to just normalize what is the metric we're seeing. So now that we have metrics from Prometheus, metrics from logs, metrics from ingestion systems, the metrics extensions are pretty much built in. We've had a few requests to get Victoria metrics in. There are other metrics platforms. Now it's just up to the community if they want to bring in other metric platforms and metric providers. The next major task we get is requests for getting alarming systems and alerting systems. So they just want to read the alerts, not really do alerts. So they can have a single pane of glass of metrics, logs, and tracing with the alerts on top. Next, let's go into logs. For logs, we have a logging UI primarily based on PPL. This is our log explorer. The log explorer supports correlations between logs and traces. We're adding logs and metric correlations going ahead. It supports log patterns, live tails, surrounding events, most of the good to have functionalities. But the key piece over here is the primary interaction is PPL, the language. You can start having investigative use cases and drilling through your workflows while you are sifting through large amounts of data in multiple indices. And with the latest edition of Spark, you can now do information retrieval from Spark and directly move it over here with acceleration. We'll cover that in a bit. Next, for traces. Traces, since inception, we had only support for Data Prepper traces. In 2021, we expanded the support to add a Jaeger and OpenTelemetry traces. Those formats are now natively supported. You can switch between all trace providers. And for tracing, applications. You can now build smaller applications with metrics, logs, and traces as a unified unit in our app analytics platform. Let's jump into OpenTelemetry a bit. Some of the key things we are doing with OpenTelemetry start with schemas. Only having OpenTelemetry integrations would ideally give us data in the OpenTelemetry format. But without schematization, without understanding the semantic conventions, we don't know what to do with the data. Having data is meaningless and almost wasteful if you don't have connections into it and understanding of it. So the base of it starts with schema compatibility. The schema compatibility issue talks about how we looked into OpenTelemetry schemas, open metric schemas, other schema systems out there, normalize them with backward compatibility so that when systems are writing schematized data, the physical manifestation of it understands which field is what and can do correlations across the board. This is the main fundamental piece that we wanted to do first before adding more and more support for OTel. So every single OTel project that we're doing has schema notions built in. For example, if using an OTel exporter for OpenSearch, the OTel exporter for OpenSearch will schematize the data as you're moving in. Today, it schematizes traces and logs. Metrics is pending. The OpenTelemetry exporter for OpenSearch is an in-progress process. That is only GitHub issue over there, still waiting a resolution and completion. I believe in the next couple of months, we should get it to close and release the OpenTelemetry exporter for OpenSearch. Next is OpenTelemetry demo. OpenTelemetry demo, if everybody has seen it over here, it's an entire shopping application set up by all the vendors and everybody in OpenTelemetry together. So everybody can test, compare, and verify how each platform works end to end. Today, we support OpenSearch in the OpenTelemetry demo. You can bring in an entire demo, scale test it with 30,000 traces per second, have other scaling parameters, and we primarily use it for benchmarking our own systems. How good are we as an observability platform? Can we scale to 30,000 traces per second? Can we scale to those crazy numbers? And if you have to go there, what are the trade-offs, choices, and heuristics we need to make? That's where the OpenTelemetry demo becomes very useful. The OpenTelemetry demo will be soon available on our playground, which is a public OpenSearch running for everybody to try out how OpenSearch works. Over there, it also serves as a demo and a tool for everybody to see how we can get metrics, logs, and traces together. Next, a recent initiative we started is there's a recent proposal in OpenTelemetry to get a standardization on a query language. How can there be one query language for OpenTelemetry? So there is nothing between multiple vendors with different query languages causing friction for customers. There are various proposals over here. We spoke about the PPL proposal a few weeks ago. I think we'll continue working with the OpenTelemetry community and seeing how far we can take PPL as a standard and make it an OpenTelemetry project and help it become an OpenTelemetry standard for queries. Once we have the schemas, OpenTelemetry support, metrics, logs, and traces, now the next challenge when we talk to customers and everybody who starts using our system is every time I go and install something, it takes me 5 days to 1 day to a month for most people to set up their dashboarding system, to set up the right query, the right visualization. It just takes too much time. This is a product called integrations. We've been working with a lot of partners over here to get more and more integrations in to enable us to do one-click experiences. As an integration, what you see is all the assets for queries, visualization assets, dashboard assets are all baked in. Behind the scenes, we also did a CLI. So new developers creating new integrations can use a CLI and an SDK to contribute more and more integrations and version control them. The goal over here has been very simply achieved by just click one button, you get everything. And all this is possible primarily because of the work went into schemas. Because without schematization, we can't really know how things are operating behind the scenes to plot any visualization. The next most important part of the project that I'm trying to work as a team over here is scalability. And how do we track scalability and low cost? Observability as a platform, we've been working with OpenSearch for a long time. And whenever we talk to customers, everybody, and even myself, when I talk to my own DevOps teams and my finance teams, the core problem is how much are you spending on observability? And then the choice comes to, should I store this field? Should I keep debug logging or info logging, or should I keep only error logging? And the fact of the matter is, these choices are difficult. When you have an error, that is the only time you know what you need. And if you don't have something, it takes a lot of time to fulfill what you wanted to solve as a problem. And because of this, we have to always choose based on cost or scale or some limitations in our system. To go around this problem, we have the lowest cost storage available today in object stores like S3. Once we have an object store, the second problem comes to is, do we now need to compute everything and process and ingest all the data? So how do we get away with OpenSearch as a heavy indexing system, ingestion jobs, and moving all the data constantly when we have to throw away everything? Almost 99% of our observable data is not useful if there is no event. But if there is an event, almost 100% of it becomes useful because you have to just go all the way around it to search and grok for it. It's a very difficult problem, and there's no heuristic that you can really tell. There have been many systems who've been doing anomaly detection here, some fancy algorithms here. But at the end of the day, when things go bad, you just need the logs in a very easy way to find it out with a good interface. You can always keep logs in S3, but then when you're woken up at 2 a.m., you have a good tool which has only X amount of data, but you don't need that. You don't have the one piece you need to debug the solution. And then you go to S3, pull something up, start grokking, and then you're back at awk, set, and grep. So how do we bridge this gap? That's the problem statement for this part. When we're evaluating this, the first step that came to is S3 is one lowest, cheapest storage. From S3, many vendors have different object stores. So the solution works across an object store boundary. So you can keep on adding adapters. OCI is one of them. Once we go to these object stores, the object stores also work at different levels. There's the object store cold, then there is Glacier and various other lower cost object storing mechanisms. Now, if we as an object store, how do we do compute? OpenSearch is a very good search platform. But if you want to do high compute and reach exabyte scales of logging data, it probably is not the best option out there to go across that scale. So what we are thinking over here is go back to old database principles. And if you go and remember back, database is 101, MySQL or any SQL database, the analogy is you take your data, insert into a table. If you're inserting your data in a table, you can search it, you can do queries on it, you can do simple operations on it, and very soon you realize this is very slow. And then the principles tell you, go create a secondary index, create a materialized view, create a covered index, create a skipping index, Bloom filter indices. These are all database techniques. So what we have done over here is effectively taken those techniques and applied them to S3. And when we apply database techniques to S3, we need an engine capable of two things. First, having a mature code base to allow us to build and enable those techniques. By definition, we need a very good query planner and a query execution engine. That is Spark Catalyst. Second, we need an engine that can do massive MPP tasks and scale at thousands of nodes. And that is Spark. And I think that's where take the object store, take Spark as an engine, and take Catalyst as an optimizer. Take these three pieces and how do we build a solution and work backwards from there so that we have to do zero ETL. So the goal of the project is don't do any ETL, move all your data, all your logs, everything as it is coming into S3 in your object stores. And now you move to OpenSearch, primarily for solutioning. So you have your dashboarding UIs, metrics UIs, traces UIs, all these UIs work on OpenSearch. How do you feed these UIs with the data over there at low cost? So we built PPL as a language again and picked this option to start having Spark support PPL. So today we have enabled from our Spark accelerator a support for PPL and SQL in Spark. This project, to be clear, is living in the OpenSearch project umbrella. It is in the OpenSearch repos, but this is a fundamental piece of a Spark ecosystem. We have built it as an independent Spark acceleration module. You can use that module to add secondary indices in Spark to manifest in OpenSearch, manifest in S3, or manifest in MongoDB, for example. You can go wherever you want. This is an independent project in the Spark community. So now that we have the fundamental technical pieces, how do we build it in a solution that works and it is very user-friendly? We can't tell every OpenSearch user now go have Spark over here, then OpenSearch over here, then build queries in between, and the UIs go wonky. So we had to do a lot of work in between the UX tiers to make everything work together. So this is where the concept of data sources comes into play. With data sources, this is where OpenSearch is now able to connect into remote systems. It does connection parameters, which is basic auth, SigV4 is there, some other options are there. You can connect these systems into Prometheus. You can go to Apache Spark, you can go to EMR. All of these systems allow OpenSearch at the lowest tiers in the backend to connect to remote data sources. Once we have those connections, the magic is primarily done by these operations of querying data and accelerating performance and defining tables. Suppose you get unstructured data, completely unstructured data in S3. It's JSON, it's CSV. You don't know what to do with it. Just take some application logs and dump them in. The step one you would execute on that is define tables for it by just writing a SQL query and extracting fields from it. This is a very common task in Spark. Spark is very popular with ETL systems. You can do simple parsing. There are many crawlers available which will just know go through your data sets, find patterns, and create tables for you. This is a basic requirement. Sometimes for new users, also a very difficult step. So how do we even simplify that further? So we go back to integrations again. And if you have integration, suppose you have VPC flow logs or Nginx logs going in, we know those schemas. Those are schematized formats. So we can create the acceleration queries and table queries beforehand. So one click, you get everything set up, you get data from Spark accelerated and visualized coming to OpenSearch. Now that you're doing your ad hoc queries and you have your tables and you want to create an acceleration index, this is standard ANSI SQL acceleration. So you could basically do create view, create skipping index, create external tables. If you are a DBA, you'll feel right at home over here. This is a space in which we didn't want to reinvent the wheel, didn't give you new concepts and new fancy UIs. So we just kept things basic for acceleration at SQL and worked with SQL acceleration to enable you to provide any semantics you need to accelerate the columns and fields you need. For example, for Nginx logs, the most common field people search on is host. After you do the host query, then you might do something else. So you dump all your data in S3. Suppose you have petabytes of data in S3. What you would create is a skipping index on the host column. So if there are, for a petabyte of data in S3, there are like 1 million tiny files. Would Spark ideally go over all the files? If you run a Spark job, yes. Spark will go over all the files. If you go with Delta or some other formats, it will still try to do some optimization, but it still doesn't have a full skipping index. But because we created a skipping index, a job in the background will start moving skipping index and tagging data sets. So next time when you do a query, PPL source equal to where hostname equal to, and then do a search query after that, and the query is supposed to span 1 petabyte of data, it will only look for the files that has that hostname. And that saves you so much scan. If you we will release benchmarks in a few weeks. Benchmarking is still on progress, but the recent benchmarks have been just crazy good. And it's not magic. It's just like we're just not looking at most of the data. So it will be fast. The other part is full text search. And full text search has also been growing at scale. And the problem is if you keep search data in OpenSearch, OpenSearch doesn't only keep search indices. It also keeps indices for retrieval. So anything you paint as a result is stored in a different data structure, and the data structures that are used for search are a different data structure. So you're actually duping most of the information, not to the dupe extent, but you have full dupes. What if you keep half of the information or most of the information in S3, and you keep only the searchable fields in OpenSearch? So now you can do your skipping indices for the hostname field and do grokking and the relevancy terms in OpenSearch. You have a perfect system that can play and give you all the levers to control cost, scale, to build your own solution. So once we have data sources with the capabilities to query, accelerate, and define tables, the next part is how do you consume this? For the consumption use cases, coming in the next releases, we're going to see most of our UIs, most of our core tools have a pattern of supporting PPL and SQL everywhere. You could do these queries. These queries will be selected by running the languages on OpenSearch itself or running the languages on the remote connections. And this is how, for an end user, you go through this seamless experience of going through your metrics in Prometheus, maybe, your data in S3, accelerations via OpenSearch, some core data that always needs to be hot in OpenSearch. And you don't really need to play the cards of like, how do I save cost? Or how do I not save some critical and important information in my OpenSearch cluster for doing log analytics? This was our journey that we started like right after fork with a small idea. And over the last 3 years, I've been just slowly and steadily chipping away towards building all the pieces of the puzzle. There's still a lot more to go. I think the next focus will primarily be very much on building domain-specific use cases with integrations, having more pre-built alerts, pre-built automated instant-on capabilities. A part of the focus will always go to how do we do correlations? How do we do detections, correlations without the user giving input into it? And the third part will always be fundamental at scale and cost. That's it from me. Thank you.